Hi and welcome to topic 4 of OCR A Level Chemistry. This is acids, and it's specifically the AS stuff on acids. Now there's also stuff in the A2, the second year of A Level Chemistry, on acids. That stuff is more complicated, but don't forget that this stuff that I'm about to go through today is also just as likely to come up in the exam as the stuff from A2. So don't forget the easy stuff. First thing you need to know is the formulae of some common acids, and the four that are on the specification are hydrochloric acid, nitric acid, sulfuric acid, and ethanoic acid. You also need to know the common alkalis, and the three that are on the specification are sodium hydroxide, potassium hydroxide, and ammonia. All acids put H+ ions into solution, and all alkalis put OH- ions into solution. Now there's a few bits here that might be confusing. With the strong acids, hydrochloric acid, nitric acid, and sulfuric acid, it's these hydrogens at the beginning which are lost into solution to make H+, leaving the negative ion as a spectator normally. But with ethanoic acid at the bottom, it's this H from the carboxylic acid, which is part, and I'll draw a picture of ethanoic acid just to show you the H, which is the acidic hydrogen. Okay, so this is ethanoic acid. It's this hydrogen of the carboxylic acid group, which is acidic, and this is the hydrogen which is lost in acidic reactions that ethanoic acid does. So when ethanoic acid acts as an acid, the H+ leaves, same as all acids, and what's left over is an ethanoate ion. With the alkalis, sodium hydroxide, potassium hydroxide, it's very easy to see where the hydroxide comes from when you put those into solution. Ammonia, however, doesn't contain a hydroxide, but when you put it into water, the ammonia reacts with the water to create ammonium hydroxide. And it's that hydroxide which makes it alkaline. This is ammonia reacting with water to make ammonium and hydroxide, and this is the alkaline part. And you also need to know the difference between a strong and a weak acid. So qualitatively, a strong acid completely dissociates when you put it into water. So these top three will fully dissociate, which means that, for instance, the H+ will separate from the Cl- completely. Every single HCl will split up into H+ and Cl- when you dissolve hydrogen chloride into water. Same with HNO3 and H2SO4. A weak acid only partially dissociates, which means that only some of the hydrogen ions are lost into the solution. Ethanoic acid is a weak acid. Most of the ethanoic acid stays as CH3COOH, and only a few, about 1 in 10,000, split up to form ethanoate and a hydrogen plus ion. You also get strong and weak alkalis. These two are strong alkalis, this is weak. Same definitions apply, but they're asked about much less frequently, so concentrate on the acids. You need to know that a neutralization reaction is a reaction between a H+ and an OH- to form water. The next thing you need to be able to do is the acid reactions. I went through them in the last video, but I didn't write any equations out. It's the metal hydroxide plus acid, metal carbonate plus acid, metal oxide plus acid, and metal plus acid. I'm also going to talk about acid plus ammonia, just to show you how the ammonia reacts as an alkali. So metal plus acid makes metal salt plus hydrogen. I'm going to call metal salts from now on. Metal hydroxide plus acid makes salt plus water. A metal oxide plus acid also makes salt plus water. A metal carbonate plus acid makes metal salt plus water plus carbon dioxide. And then an acid plus ammonia makes an ammonium salt. So I'll give an example for that one just because it's a little bit strange. Hydrochloric acid plus ammonia would make ammonium chloride. It's also worthwhile at this point talking about the names of the salts. The metal is just the name of the metal. The second part of the salt is the second part of the acid. So chloride or nitrate or sulfate or ethanoate. Also contained in this part of the specification is how to conduct a titration and the calculations which go along with titration. Now, for that, I accidentally did it in the last video. It's because that was about moles, and there's a lot of mole stuff in a titration calculation. So if you want to know how to do a titration, it's in the last video, topic 3. But I will quickly talk about the techniques and how to make a standard solution, which is useful in titration. So, for example, if you want to make 250 centimetres cubed of potassium hydroxide solution at a concentration of 0.2 moles per decimetre cubed, how would you do that? First of all, you need to work out how many moles are going to be present in 0.2 moles per decimetre cubed and 250 centimetres cubed. And to do that, you multiply the volume by the concentration. Okay, so I've divided 250 by 1,000 to get into decimetres cubed, times it by 0.2, which was the concentration, to get 0.05 moles. So 0.05 moles needs to go into the volumetric flask first, so you need to know how many grams that is, so what's the mass. To do that, you multiply the number of moles, or the amount of substance, by the molar mass. And you can calculate the molar mass by using the formula unit, which is KOH. So potassium's relative atomic mass is 39.1, oxygen's is 16, and hydrogen's is 1. So you add those together to get the relative formula mass. So the relative formula mass is 56.1. That means the molar mass is 56.1 grams per mole. So I times that by the number of moles that I need. That works out the mass that I'll need. So I've rounded it to 2.81 because it's in 3 significant figures and everything else is in 3 significant figures. So you need to put 2.81 grams into a 250 centimetre cubed volumetric flask, and then put in a little bit of distilled water, and dissolve it, and then make that solution up to 250 centimetres cubed. Then you've got a standard solution of exactly 0.2 moles per decimetre cubed. And you can use that in a titration to calculate the concentration of an acid. And that's everything there is to know about acids in this part of the specification. Hope you'll join me for the next one. Goodbye.